Hello ladies and gentlemen, welcome to Edward Teaches Computers. Computers have taken a very large part in our lives, no doubts there. In spite of that, many people often still feel confused and unsure about how these machines work and how to use them. This video, and the ones that will follow, hopes to address this issue by explaining computers in a simple and intuitive manner. So, let us begin. By definition, a computer is a machine that computes. It makes mathematical calculations, much like a calculator does. So how exactly then does a computer do that? Well, to perform this function, a computer has four basic components. They are the CPU, the RAM, the hard drive, and the motherboard. Now immediately we see the first barrier to understanding more about computers: the terminology. Computer scientists weren't always the most creative of people, and often for their gadgets that they created to do a certain job, they gave it a descriptive phrase as a name. For example, CPU stands for Central Processing Unit. But that, saying it 5 times in a sentence, becomes a mouthful, hence why they called it CPU, and the name more or less stuck. But it left very little explanation behind as to what the 3 letters stood for unless one really went and found out. As we go on, we're going to cover these 4 components and explain what they do little by little, one step at a time. So, let's start with the CPU. The first component we are going to cover is the CPU, the Central Processing Unit of the computer, which we today just call processor. The processor determines how fast a computer can perform. It is determined by how many decisions a processor can make every second. Consider, for example, a set of math problems that a person has to solve. That person's performance would be rated in how many questions he or she solves every minute. Likewise, a processor's rating is determined by how many decisions it takes every second. Modern processors can make billions of decisions every second. Of course, rather than saying billions of decisions per second, 5 times in the same sentence, we call that a gigahertz. Hertz referring to 1 time per second, giga referring to billion. For example, my computer runs at 2.66 gigahertz. That means that the processor inside can make 2,660,000,000 decisions every second. There are other factors involved in the rating of a processor, but its speed, its frequency, its clock speed, is its primary factor. Let us go back to the math problem solving analogy. As a person solves math problems, it would be nice to have a sheet of paper on which one can jot down information, a carryover, for example. Now, a computer requires similar things. It needs a place to jot down information for temporary usage. That space we call RAM, Random Access Memory. Why it is called RAM, why it is called random access, is not important, which is why nowadays it's simply just called memory. Now, a person might measure how much quick jot down space he or she has in terms of 1 sheet of paper, 2 sheets of paper, a whiteboard, or an entire wall worth of space. Computers, however, measure this in a much more precise unit. They measure it in terms of data space in a unit we call the byte. Now, how much space is 1 byte? 1 byte is approximately the space that is required in memory to store 1 character. If I type A, B, or any character of the alphabet into my computer, I will have put approximately 1 more byte of data into memory. Now, how much memory does a computer have nowadays? The general amount is around 4 gigabytes. Now, is that a lot of space? Yes, it is. Most people will not need any more than that. Of course, with later years, with the trend going, we will surely see memory increasing in size just as processors get faster and hard drives get bigger. third component inside a computer is the hard drive, or storage. Once you've done your math assignment, it would be unfortunate to see it go to waste. And so, in order to hand it in the next day, you would store it in a folder or a binder and then put it on a bookshelf for safekeeping. A computer does the similar thing, and it stores data permanently inside the hard drive. Now, we said that memory, RAM, stores data, and the hard drive also stores data. So what is the difference between the two then? Well, the difference lies exactly as we mentioned. The difference is that of a whiteboard and a bookcase. In a computer, memory stores data temporarily, just as jot-down space for the computer. The biggest difference also lies in that memory needs constant power in order to keep track of data. That means that if there's a power outage, information stored on memory will simply be wiped out, whereas information stored on a hard drive remains. That is why the document you are working on can be lost if there's a power outage if you do not save often. So how big are hard drives then? Well, the unit of storage is also gigabytes. Giga meaning billion, bytes meaning billion. So is that a lot of space for storage? And how many gigabytes does a hard drive have? Computers today ship with hundreds of gigabytes of hard drive space, of storage space. 320, 500, 750, and 1000 gigabytes are common sizes of hard drives. So how much space is that then for your files, which is what you store and save on your computer? To put things in perspective, a document can take a few kilobytes, a few thousand bytes. They contain thousands, tens of thousands, or hundreds of thousands of characters, perhaps a few million if it's a very long one. They therefore take a few kilobytes or maybe 1 megabyte. 1,000 megabytes can fit in a gigabyte, and 1,000 kilobytes are stored in a megabyte. So for text files, 1 gigabyte is a very large amount of room. In fact, it's also a large amount of room for pictures and photos, both of which take maybe a few megabytes as well. 1, 2, up to 5 perhaps. Again, 1,000 megabytes in a single gigabyte, and you have hundreds of gigabytes in a modern computer. Video files take a bit more room, and that is when the hundreds of gigabytes or even 1,000 of gigabytes come in handy. Each video file, depending on the size, depending on how long it is and what's the resolution of the video, it can take a few hundred megabytes or even a few gigabytes. The biggest difference one therefore notices is that the hard drive is much larger than the memory, and that is absolutely normal. One does not store information permanently in memory, it is stored in hard drive. The final component in a computer is the motherboard. To go back again to the math problem solving analogy, we mentioned that your brain would be like the processor, working to solve the problems, with a sheet of paper to jot down information and a bookshelf to store it permanently on. But where are you doing this math assignment? You may be doing it in your bedroom, in an office, in a classroom. You have an environment in which you work, in which every one of these components fits in. Same thing for the computer. The motherboard is one of the largest pieces of hardware, pieces of machine inside your computer, on which everything else plugs in. Just like a room has a limited space for amount of bookcases, amount of tables, amount of people that can fit in, a motherboard will have a limit in terms of how much things it can handle, how many components can it take in at once. Most motherboards have a support, they have space, they have an opening for a few what we call sticks of RAM, the physical component that holds the RAM, the memory. They have a few plugs for a hard drive and usually space for one processor. The motherboard is what connects everything together and allows all the components to talk to each other. So those are the four components. inside a computer. Now, one might wonder, does one not need a monitor, keyboard, or mouse to work with modern desktop computers? Well, yes, one does. But for a computer to do its job, to compute data, it only needs these 4 basic components. Everything else is optional for the computer itself. If you consider, for example, what we call servers, computers that give web pages to other computers across the internet, a lot of servers don't have monitors, keyboards, or mice. They are connected to other servers, which then might have a monitor, keyboard, and mouse in order to communicate with a person. But those servers themselves don't need to tell anybody anything, because their job is to store and give access to web pages to your computer. Your computer needs a monitor in order to interact with you. But for the server to have done its job as a computer to compute data and send it out, it did not need a monitor, nor did it need a keyboard or a mouse. These items we call peripherals. They are around the computer. There are also a few internal components of a computer that we have not mentioned in this first episode. As the rest of the videos come, they will be covered one by one with more detail. The components that we have covered today, we will also visit again and explain a few more subtle factors about them. Until next time, however, I hope that this video has given you a better understanding of computers in order for you to know a bit more about them. Until next time then, thank you for watching.